Very good afternoon to all of you. हम लोग CFT देख रहे थे ना, तो ऑलमोस्ट वी हैव फिनिश दिस चैप्टर. हम लोगों ने चैप्टर ऑलमोस्ट कंप्लीट किया है. टुडे वी विल सी वेरी important point, that is Jahn-Teller distortion. Today we will see Jahn-Teller distortion. This Jahn-Teller distortion is also very important. ठीक है. In the last lecture, I think we have seen application of CFT to the tetrahedral complexes. How to calculate CFSE, that is crystal field stabilization energy, for the tetrahedral complexes that we have seen. Then lastly, in the last topic we have seen calculation, crystal field spectra, or calculation of 10 dq or del O value in terms of energy, that we have seen. So today we will see one more important point, that is tetragonal distortion and Jahn-Teller distortion. So this distortion generally occurs in case of octahedral complexes. This distortion is generally occurs in case of octahedral complexes. Distortion means what? Distortion means, for example, if you have perfect octahedron, that means all the bond length of that octahedrons are similar. So octahedral complexes, coordination number 6, that means there are 6 ligands attached to the central metal atom. 6 ligand attached means there are 6 bonds are present, and all that 6 bonds, they have same bond length. They have same bond length. And if in case due to some factors, or due to some what we can say, uh, difference in electronic configuration, the bond length, all the 6 bond length, they will not remain same. So axial bond length, they will get increase or they will get decrease. Okay, so in octahedral geometry there are two types of bonds. 4 ligands and metal, they are in one plane. So that 4 ligand and metal which are in one plane, they are called as equatorial ligand. They are called as equatorial ligand. And one ligand is above the plane and another ligand is below the plane. So these above the plane and below the plane, these ligands, they are called as axial ligands. So they are called as axial ligands. So due to some difference in electronic configuration, this distortion takes place. Okay, so we will start today's lecture. So this is your lecture number 6 of crystal field theory. ठीक है, हम लोग क्रिस्टल फील्ड थ्योरी का लेक्चर नंबर 6 देख रहे हैं. ठीक है, सो विल स्टार्ट the tetragonal distortion, or sometime it is also called as a Jahn-Teller distortion. Most popularly it is known as a Jahn-Teller distortion. ज्यादा इसे जॉन टेलर डिस्टॉर्शन के नाम से जाना जाता है. देयर आर टेट्रागोनल डिस्टॉर्शन, अनदर नेम इज आल्सो देयर, दैट इज tetragonal distortion, because after the distortion of perfect octahedral, tetragonal geometry is formed. That's what is called as a tetragonal distortion. Now why this occurs, I have tell you. So distortion means what? Distortion means, for example, suppose your metal is here and there are 4 ligands. Ligand, second ligand is here, third ligand is here, and fourth ligand is here. So these ligands, they are called as equatorial ligands. They are called as equatorial ligands. And two ligands, they are called as a axial ligand. They are called as axial ligand. They are called as axial ligand. So this is a perfect octahedron. This is a perfect octahedron. Perfect octahedron means all the bond length of these 6 ligands, it is same. All the bond length of these 6 ligand, it is same. So it is called as a परफेक्ट ऑक्टाहेड्रॉन, जिसमें 6 के 6 बॉन्ड लेंथ इक्वल है, सिमिलर है, इट इज कॉल्ड एज ए परफेक्ट ऑक्टाहेड्रॉन. So in this case there is no Jahn-Teller distortion or no tetragonal distortion, but distortion occurs due to some difference in electronic configuration. Okay, so here the two axial ligands whose bond length is smaller as compared to the equatorial ligand. So this is also a one type of Jahn-Teller distortion. Another type of Jahn-Teller distortion is this one. Here the axial ligands, they have larger bond length than the equatorial ligand. So these two types of distortions are there. This is one and this is two. So these two types of distortions are there. Okay, all of you understood what is distortion? Distortion समजले का सगळ्यांना? First tell me that, then we will go to the why this distortion takes place, what are the different factors responsible for this distortion. Okay, why this axial compression takes place. This first case it is called as axial compression, please remember this. This first case it is called as axial compression, and this second case is called as axial elongation, because these bonds are, this is your z axis, please remember, this is your z axis, this is your z axis, and by default z axis is taken as a axial axis. So these two ligands, these axial ligands, they get compressed, in first case, so it is called as axial compression, and here they get elongated, axial ligands, they get elongated, so it is called as axial elongation. ठीक है, understood all of you? ये समझ में आया आप लोगों को what is mean by distortion? Then we will see why this distortion occurs. What is the factor which is responsible for this distortion? This distortion generally occurs due to the unsymmetrical filling of electrons in the T2G and EG orbital. It occurs due to what? Unsymmetrical filling of the electrons in T2 and EG orbital. Okay, so have you understand? Sonal is saying yes sir, only Sonal have understand the distortion concept. Okay, first understand this concept of distortion, then we will see what is tetragonal distortion and what is Jahn-Teller distortion, why this Jahn-Teller distortion takes place, that we will see. Okay, now I will remove this. Okay, so this distortion when it occurs, so the first point, see आपके screen पे, when d orbitals of central metal ions, when the d orbitals of central metals ions are not filled symmetrically, then the regular shape of octahedral complex is get distortion. So this is the first reason. This is first reason when tetragonal distortion or Jahn-Teller distortion takes place, when the d orbitals of central metal atoms are not filled symmetrically. When the d orbital of central metal atoms, they are not filled symmetrically, then the regular shape of octahedral complex is get distorted. This is the first reason. Then second reason, second point क्या है? See here, Jahn-Teller distortion takes place when T2G or EG set of orbital contains neither completely filled nor half filled. कब होता है ये Jahn-Teller distortion? When T2G and EG set of orbital contains neither completely filled or nor half filled orbital. If this is the case, then Jahn-Teller distortion takes place. If this is the case, then Jahn-Teller distortion takes place. These 2 points are there. When the d orbital of central metal atoms are not filled symmetrically, then the regular shape of octahedral complexes get distorted, or another way we can say that when T2G or EG set of orbital contains neither completely filled nor half filled orbital, then the Jahn-Teller distortion or tetragonal distortion takes place. Okay, understood? Okay, then we will see what is mean by symmetrical filling of electrons. Here word is I have written in red color. Okay, so what is mean by symmetrical filling and what is mean by unsymmetrical filling? When the electrons in T2G and EG orbitals, if they are symmetrically filled, if they are symmetrically filled, sorry, let me check this one. Let me check this one first of all. Correct, correct, correct. When the d orbital of central metal atoms are not symmetrically filled, then the regular shape of octahedral complex is get distorted. Okay, so what is mean by symmetrical filling and unsymmetrical filling of the orbital, that we will see, Okay, so here I will take d6 system. Here I will take d6 system, and the complex is, suppose it is a strong field complex. The complex is strong field and your system is d6. Then d6 system means you have 6 electrons, 1, 2, 3, 4, 5 and 6. We have 6 electrons in free metal ion and we have to fill these 6 electrons into T2J and EG orbital. So first of all, according to the rule, first 3 electron will go into the T2J orbital. Okay, according to the rule, first 3 electrons will directly go into the T2J orbital. Then the fourth electron will go into EG or T2J orbital. Tell me, जो फोर्थ इलेक्ट्रॉन है वो ईजी में जाएगा या T2 में जाएगा, दैट यू हैव टू टेल मी. Complex is strong field, please remember this. Complex is strong field, so whether it will go in T2G or EG, tell me. कहाँ पे जाएगा इलेक्ट्रॉन नंबर फोर्थ इलेक्ट्रॉन जो है वो किस ऑर्बिटल में एंटर हो जाएगा? कोमल इज सेइंग EG. नो EG. व्हाई EG? EG में जब जाता है जब वीक फील्ड होता है, सो इट विल गो इनटू T2G. So fourth electron will go into T2G. Then fifth electron will also go into T2G. Sixth electron also will go into T2G. So its electronic configuration will become T2G6 and EG0. Its electronic configuration will become T2G6 and EG0. Okay. Now here T2G, how many T2G orbitals are there? 3 T2G orbitals are there, and capacity of one orbital is 2 electrons. So 3 orbital can occupy 6 electrons. 3 orbital can occupy 6 electrons. So if this is the condition, then it is called as a symmetrical filling of electrons. Then it is called as symmetrical filling of electron. Understood what is mean by symmetrical filling? समझ में आया symmetrical filling? Symmetrical filling कब symmetrical filling होता है? When the orbital is half filled or completely filled. When the orbital is half filled or completely filled, then that is called as a symmetrical filling of electron. Then it is called as a symmetrical filling of electron. ठीक है, समझ में आया what is mean by symmetrical filling of electrons? What is mean by symmetrical filling of electrons? When the orbital contains exactly half filled or completely filled orbital, then that orbital is called as a symmetrically filled orbital. Then that orbital is called as symmetrically filled orbital. Understood this symmetrical filling of electrons? समझ में आया? Tell me. Then we will go to the unsymmetrical filling of electrons. Then we will go to the unsymmetrical filling of electrons. Have you understood it or not? Tell me. Have you understood it? Okay, Jay is saying yes sir. Amit is also saying yes sir. What about others? Anisha, Renuka, Ankush, Vikram, Good, very good. So we will see the unsymmetrical filling of electrons. Then we will see unsymmetrical filling of electrons. Now here, see in this another figure, I will take D6 system only. Here also I will take D6 system, but here the complex is weak filled. But here the complex is weak filled. Now you have 6 electrons in the orbitals, 1, 2, 3, 4, 5 and 6 electrons, and you have to fill these 6 electrons, into T2G and EG orbital. But in this case complex is weak filled, so according to the rule, the 3 electrons will go into T2G orbital, 3 electrons will go into the T2G orbital, and the fourth electron will go into EG orbital. Now the fourth electron will go into the EG orbital, because the complex is weak filled. Complex weak filled means gap between T2G and EG level is less. Gap between T2G and EG level is less, and pairing energy is more. Pairing energy is more. Pairing energy means energy required to pair the electrons. Pairing energy means energy required to pair the electrons. So here in weak field complex, pairing energy is higher than the 10 dq. So electron will prefer to go into the EG orbital. Then fifth electron will also go into the EG orbital. Fifth electron also go into the EG orbital. Then sixth electron again will go into the T2G orbital. Sixth electron again go into the T2G orbital. So here electronic configuration will become, T2G 4 and EG2. T2G4 and EG2. Now if you consider T2G orbital, let us first consider T2G orbital. So here the total capacity of T2G orbital is 6, and here 4 electrons are there. So it is neither completely filled nor half filled. So it is unsymmetrical filling. So this filling is called as unsymmetrical filling. This is called as a unsymmetrical filling of electrons. Okay. Now here, see in case of EG, it is exactly half filled. So it is called as a symmetrical filling. It is called as a symmetrical filling. So understood symmetrical and unsymmetrical filling? Yes or no? Have you understood it? Symmetrical filling of electrons or unsymmetrical filling of electrons? When simple है, कुछ भी नहीं है. When the orbital is half filled or completely filled. When the orbital is exactly half filled or completely filled, then that orbital is called as a symmetrical filling. Symmetrically filled. Then that orbital is called as symmetrically filled. And when it is less than half filled, or less than completely filled, then it is called as a unsymmetrical filling of electrons. Very simple है, ठीक है? Okay, सब लोग बोल रहे हैं कि yes sir, we have understood. Okay, then we will go to the next example. Let us take D4 system. And your complex is weak filled. D4 system and your complex is weak filled. So you have to fill the 4 electrons. You have 4 electrons here in free metal ion, and you have to fill the 4 electrons in weak field complex in T2G and EG orbital. So draw this diagram and fill the electrons, 4 electrons in T2G and EG orbital according to the rules. Apply that rules and tell me the electronic configuration. Then we will see whether this electronic configuration is symmetrically filled or it is unsymmetrically filled. Okay. So first tell me the electronic configuration. Fill the electrons according to the rules and tell me the electronic configuration. You have 4 electrons in free metal ion. So that means you have D4 system. Your system is D4. ठीक है, बोलो जल्दी से. Tell me electronic configuration. T2G3 EG1, correct. Sonal and Vikram. Correct. So according to the rule, what happens? These three electrons will enter into T2G orbital. According to the rule, three electrons will enter into T2G orbital, and the fourth electron will go into the EG orbital because the gap between T2G and EG orbital is less. So the electron will prefer to go into the EG orbital. So electronic configuration is T2G3 and EG1. So here it is symmetrical filling. Here it is symmetrical filling, and here unsymmetrical filling. Here unsymmetrical filling of electron. Okay. Then take the second example, that is D4 system and complex is strong field. D7 system and complex is strong field. Now you have D7 system means you have 7 electrons in free metal ion. 7 electrons in free metal ion you have 5, 6 and 7. ठीक है, 7 इलेक्ट्रॉन्स आपके पास है फ्री मेटल आयन में. And in octahedral complex, in octahedral splitting, you have to fill the electrons in T2G and EG. So fill the electrons in T2G or T2G and EG, and tell me the electronic configuration T2G or EG. Here your complex is strong field. Your complex is strong field. T2G6 correct, Vishwajit, very good. T2G6 and EG1. T2G6 and EG1. This is the electronic configuration. Now let us see. Correct था विश्वजीत, क्यों ये किया? T2G6 and EG1. Correct. So according to the rule, 3 electrons will enter into T2G orbital. Now fourth electron again enter into the T2G orbital because the gap between, in this case, gap between T2G and EG orbital is more. So energy required to go into EG orbital is higher than the pairing energy. So electron will prefer to the pair. Then fifth electron also go into the T2G orbital. Sixth electron also go into T2G orbital. So here the capacity is completed. Then the seventh electron will go into EG orbital. Seventh electron will go into the EG orbital. Now this filling here orbital. See, orbital is completely filled. Orbital is completely filled means it is symmetrical or unsymmetrical? Tell me. T2G का जो है इलेक्ट्रॉनिक कॉन्फ़िगरेशन वो सिमेट्रिकल फील्ड है अनसिमेट्रिकल फील्ड है? बोलो. T2G is symmetrically filled or unsymmetrical filled? Tell me. Symmetrical, correct. Jay Vikram, very good. Very good. So it is symmetrical filling. It is symmetrical. And EG it is unsymmetrical filling. It is unsymmetrical filling. So when the orbitals are unsymmetrically filled, then the tetragonal distortion takes place. Then Jahn-Teller distortion takes place. Understood? When Jahn-Teller distortion takes place? When the orbitals are unsymmetrically filled. When the orbitals are unsymmetrically filled. Or when not Jahn-Teller distortion will not take place, when the orbitals are symmetrically filled. That means exactly half filled or completely filled. Then that case Jahn-Teller distortion will not take place. Okay? Okay. Okay. So you have understood. One more take one more example. D9 system, strong and weak field. So D9 system in strong and weak field it is same. ठीक है, अगर D9 system है तो whether the complex is strong field or weak field doesn't matter. So you have 9 electrons in free metal ion. You have 9 electrons in free metal ion. So I will draw here 9 electrons in free metal ion, and you have to fill these electrons in T2G and EG orbital. ठीक है, चलो करो जल्दी से फिल और बोलो मुझे इलेक्ट्रॉनिक कॉन्फ़िगरेशन. बोलो जल्दी से। इलेक्ट्रॉनिक कॉन्फ़िगरेशन बोलो। T2G6 correct, very good Vishwajit. T2G6 and EG3. T2G6 and EG3. This is the electronic configuration. Now let us see कैसे आता है electronic configuration according to the rule. First electron will go into the T2G orbital, then we'll fill the fourth electron in EG, then sixth, 7, 8 and 9. So T2G 6 and EG. So this is T2G is symmetrically filled. T2G is symmetrically filled and EG is unsymmetrically filled. Unsymmetrically filled. ठीक है, ठीक है, अंडरस्टूड. सो जो आप लोगों ने अभी केसेस देखे ना, D4, D7, D9, these all can show a tetragonal distortion or they can show a Jahn-Teller distortion. Please remember this. ठीक है. T2G is symmetrical filling. कोमल ताटे, very good, correct, सही आंसर है, बरोबर उत्तर दिले कोमलनी. चलो, then we will see the statement. What is the statement of Jahn-Teller distortion or Jahn-Teller theorem? What is the statement of tetragonal distortion? This statement is also very very important. ये statement भी आता है. Write down the statement or define the Jahn-Teller distortion or tetragonal distortion or Jahn-Teller's theorem. So when this question is there, so you have to write the statement. So what is the statement? आपके screen पे, see carefully or listen carefully. Any non-linear molecular system. Any non-linear molecular system means octahedral molecular systems in a degenerate electronic state will be unstable. In a degenerate electronic state will be unstable. कौन सी भी non-linear molecular system है, अगर उसका electronic configuration degenerate है, that means all the orbitals they are same in energy, then it is unstable. Then it is unstable. So it will undergo some kind of distortion. It will undergo some kind of distortion which will lower its symmetry, which will lower its symmetry, lower रहेगा यहाँ पे, which will lower its symmetry and lower its energy, which will lower its symmetry and which will lower its energy, and splitting of the degenerate state is occurs. And the splitting of the degenerate state is occur. So what is the meaning of this statement? Any nonlinear molecular system means octahedral system when it is in degenerate electronic state. The degenerate means all the orbitals they are in same energy level. It is unstable. वो क्या रहती है? Unstable रहती है. And to become a stable, it will undergo distortion. वो क्यों distortion undergo होता है उसमें? Because to get a stability. To get a stability. So due to the distortion, what happens? That system, that non-linear system gets a stability. And why this non-linear system gets the stability? Because there is lower in symmetry takes place, there in lower in energy takes place, and due to this lower in symmetry, lower in energy, the result is splitting of the degenerate state. The result is splitting of degenerate state. So this is the statement of Jahn-Teller distortion or tetragonal distortion. ठीक है? Okay. Then next point is the ions having. Write down this statement, please, all of you. Write down this statement, which is very very important. Which is very very important. Write down. Take pen, notebook, and write down this statement. Okay. Then the second point is the ions having unsymmetrical electronic distribution in EG orbitals. The ions having unsymmetrical electronic distribution in EG orbital are expected to have this kind of distortion. कौन सा? Jahn-Teller distortions. Which compound have Jahn-Teller distortion? The ions or metal ions having unsymmetrical electronic distortion in EG orbital are expected to have this kind of distortion. That means when the EG orbital contains 1 or 3 electrons, when the EG orbital contains 1 or 3 electrons, then Jahn-Teller distortion takes place. Very simple. क्या है? बहुत ही simple है. When the EG orbital contains 1 or 3 electrons, then automatically its filling is unsymmetrical. then automatically its filling of electrons will become unsymmetrical, and then the Jahn-Teller distortion takes place. Very very important when the Eg orbital contains 1 or 3 electrons. Okay, so this is the second point. Then third point is a similar but smaller effect is expected. A similar but smaller effect is expected when T2G orbitals are unsymmetrically filled. What about T2G? अगर T2G में भी unsymmetrically filled electrons है तो उसमें भी जॉन टेलर डिस्टॉर्शन होता है, लेकिन उसकी इंटेंसिटी और उसकी मैग्नीट्यूड Eg से कम होती है. ऐसा नहीं है कि T2G अनसिमेट्रिकल फिल होने से जॉन टेलर डिस्टॉर्शन नहीं होता है, but its magnitude is less as compared to the Eg orbital. Its magnitude is less as compared to the Eg orbital. So क्या है point number 3, a similar but smaller effect is expected when T2G orbitals are unsymmetrically filled. That means when T2G orbital contains 1 electrons, 2 electrons, 4 electrons and 5 electrons, then the smaller Jahn-Teller distortion will take place. Then smaller Jahn-Teller distortion will take place. ठीक है, you understood? अगर Eg में unsymmetrical filling होता है इलेक्ट्रॉन्स का तो उस केस में Jahn-Teller distortion की मैग्नीट्यूड ज्यादा रहती है. उस केस में Jahn-Teller distortion की मैग्नीट्यूड ज्यादा रहती है. एंड T2G ऑर्बिटल में अनसिमेट्रिकली इलेक्ट्रॉन की फिलिंग होती है तो उसकी मैग्नीट्यूड कम रहती है, उसकी मैग्नीट्यूड कम रहती है. सो ये सेकंड और थर्ड पॉइंट का मीनिंग है. ये क्या है? सेकंड और थर्ड पॉइंट का मीनिंग है. अंडरस्टूड ऑल ऑफ यू दिस? समझ में आप लोगों को? यस और नो? जेव्हा जेव्हा Eg ऑर्बिटल मध्ये इलेक्ट्रॉनचं फिलिंग हे अनसिमेट्रिकल असेल तेव्हा तेव्हा जॉन टेलर डिस्टॉर्शन ची मैग्नीट्यूड ही खूप जास्त असते. सिंपल. एंड व्हाट अबाउट Eg? अगर Eg में भी है तो उसमें स्मॉलर है, इफेक्ट इज स्मॉलर. ठीक है, अंडरस्टूड. वेरी गुड, यू हैव अंडरस्टूड. नाउ एवरीवन इज सेइंग यस सर. वेरी गुड, समझ में आप लोगों को अच्छी बात है. नाउ माय क्वेश्चन इज व्हाई the magnitude of Eg orbitals are more than the magnitude of T2G orbital. ठीक है, why the magnitude of Jahn-Teller distortion in unsymmetrical filling of Eg orbital is more as compared to the magnitude of T2G orbital. Why this is so? ठीक है. Now anybody know why this happens? Anybody knows why this happens? ये आप लोग इसका आंसर आप लोगों को पता है. आई नो दैट कि यू नो दिस आंसर. आई नो दैट कि आप लोगों को ये आंसर पता है. सिर्फ आप लोगों को दिमाग लगाना होगा आपका. यू हैव दैट नॉलेज. जस्ट अप्लाई दिस नॉलेज इन दिस केस. यू विल गेट द आंसर. Anybody knows the answer? Please tell me. Because Eg orbital is higher in energy and more stabilization is required. Not exactly correct. Not exactly correct. Why the magnitude of Jahn-Teller distortion in case of Eg orbital is more as compared to the T2G orbital? Eg is higher in energy. No. Why is it higher in energy? Tell me now. Why Eg orbital is higher in energy? Why Eg orbital is higher in energy? मैंने फर्स्ट लेक्चर में आप लोगों को बोला है, कि पॉइंट्स टू रिमेंबर. इसमें मैंने आप लोगों को बोला था. नहीं पता? ठीक है. नाउ लिसन केयरफुली. While octahedral complex because of axial approach of ligand. Correct, Prachi, very good. Correct, very good, because of axial approach of ligand. Now listen carefully the answer. While formation of octahedral complex, CFT considers the approach of ligands is along the axis. क्या है? While octahedral complex formation, CFT considers the approach of ligand is along the axis, and EG orbital have their lobes pointed along the axis. So orbital and incoming ligand, there is more interaction means automatically their energy will get increase. So due to this, when there is unsymmetrical filling of electrons in EG orbital, that means it will experience uh, unsymmetrical repulsion, or it will experience somewhat different repulsion from the ligands. Okay? And when there is a symmetrical filling of electron take place, that means all the ligands in that axis, they will experience same repulsion. All the ligands, they will experience same repulsion. And if the unsymmetrical filling is takes place, that means 1 or 3 electrons in EG, then that means it will experience different ligands will experience different repulsion. Okay? So due to this, what happens? Due to this, the magnitude of EG orbital is more while talking about the Jahn-Teller distortion. Okay? Understood? Okay, chalo. Then we will go to the next point. Now there are two cases of Jahn-Teller distortion. Which two cases are there? So case number one is here. आपके स्क्रीन पे केस नंबर 1 क्या है? Let us forget about this. Okay, no problem, we will take. Let us consider, for example, EG orbital has 3 electrons. Let us consider, for example, EG orbital has 3 electrons. Now what happens? Here I will write 3 electrons. Now what happens if in this case dx square, EG orbital means which orbital? Dx square minus y square and dz orbital, dz square. These are EG orbitals. You know that when dx square minus y square is lower in energy, this is the case 1, when dx square minus y square is lower in energy and dz square is higher in energy. Now here splitting of EG orbital takes place. ठीक है ना? यहाँ पे क्या हो जाता है? Splitting of EG orbital takes place. So here in first case, two cases are there. पहले केस में क्या होगा? पहले केस में dx square minus y square is lower in energy होगा, and second केस में dx square minus y square will be in higher in energy. These two cases are there. So let us see for case number 1. In that case number 1, dx square minus y square, this orbital is lower in energy and dz square is higher in energy. ठीक है? Understood? Then you have 3 electrons. आपके पास 3 electrons है. ये 3 electrons आप लोगों को dx square minus y square and dz square में fill करने according to the rule. Fill करने आप लोगों को. So according to the rule, what happens? The electrons will go into the lower energy orbital first. So here dx square minus y square is lower in energy. So first electron will go into the this orbital, dx square minus y square. Then another electron will go into the same orbital, that is dx square minus y square, and third electron will go into the dz square. That means here electronic configuration will become dx square minus y square 2 and dz square 1. This is the electronic configuration. So this is the electronic configuration. So if this is the case, then what will happen? If this is the case, then axial compression takes place. If this is the case, then axial compression takes place. That means ये आप लोगों का डिस्टॉर्शन होगा. ये आप लोगों का क्या होगा? डिस्टॉर्शन होगा. If this is the case, then axial compression takes place. When the electronic configuration is when the electronic configuration is dx square minus y square 2 and dz square 1. When this electronic configuration is there, then axial compression takes place. Axial compression takes place. Why it is called as axial compression? Because axial ligand they will get compressed. Axial ligand they will get compressed. So these axial ligands are there. These axial ligands are there. They will get compressed. So when the electronic configuration is dx square minus y square 2 and dz square 1, then axial compression takes place. ठीक है? तो ये कैसे याद रखना है आप लोगों को? मैं आप लोगों को मेरी ट्रिक बोलता हूँ. It is not there is no scientific reason for that, but just to remember, मैं आप लोगों को कैसे याद रखता हूँ मैं आप लोगों को बोलता हूँ. See here, in dz square only one electron is there, and in dx square minus y square 2 electrons are there, and this is your z axis. I have told you this is your z axis. So dz square orbital is along the z axis, dz square along orbital is along the z axis. एंड अगर आप लोग देखोगे तो dz स्क्वायर में एक ही इलेक्ट्रॉन है, मतलब इससे कम है. dx स्क्वायर माइनस y स्क्वायर से क्या है, कम है. तो z एक्सिस वाले बॉन्ड्स की बॉन्ड लेंथ भी क्या होगी, कम होगी. अगर dz स्क्वायर में इलेक्ट्रॉन्स कम है तो उसकी बॉन्ड लेंथ कम होगी. या ऐसे मैं याद रखता हूँ. दिस इज माय फंडा. ठीक है, दिस इज माय ट्रिक टू रिमेम्बर दिस. ठीक है, अगर dz स्क्वायर में इलेक्ट्रॉन्स कम है तो एक्सियल कंप्रेशन होगा. दैट मींस एक्सियल लिगेंड्स की और एक्सियल बॉन्ड्स की बॉन्ड लेंथ वो कम होगी, बिकॉज ऑफ देयर इज लेस इलेक्ट्रॉन. देयर इज लेस इलेक्ट्रॉन. सो दिस इज द केस नंबर 1. अंडरस्टूड केस नंबर 1? टेल मी, सब लोगों को समझ में आ गया? केस नंबर 1, व्हेन dx स्क्वायर माइनस y स्क्वायर 2 and dz square 1, if when this electronic configuration is there, then axial compression takes place. Then axial compression takes place. ठीक है, समझ में आया? Tell me. Correct. Very good. Correct. चलो, जय, विश्वजीत, कोमल, रेणुका, they are saying yes sir. So case 1 is over. Case 1 is over. Now we will see the case number 2. We will see the case number 2. We will see the case number 2. In the case number 2, what is the condition? केस नंबर 1 के एग्जैक्ट अपोजिट कंडीशन है. क्या है? केस नंबर 1 में dx स्क्वायर माइनस y स्क्वायर दिस ऑर्बिटल इज लोअर इन एनर्जी. केस 1 में क्या था? ये जो ऑर्बिटल था dx स्क्वायर माइनस y स्क्वायर, ये लोअर इन एनर्जी था, एंड dz स्क्वायर ये हायर इन एनर्जी था. इसमें क्या है? इसमें एग्जैक्टली अपोजिट कंडीशन है. हियर dz स्क्वायर is lower in energy and dx square minus y square is higher in energy. So now this is 2 Eg orbital. You know that this is 2 Eg orbitals are there, and we have 3 electrons. In Eg orbital you have 3 electrons, and these 3 electrons you have to fill in dz square and dx square minus y square. So according to the rule, what happens? dz square में 2 इलेक्ट्रॉन जाएंगे एंड dx स्क्वायर माइनस y स्क्वायर में एक इलेक्ट्रॉन जाएगा. सो इट्स इलेक्ट्रॉनिक कॉन्फिगरेशन विल बिकम dz स्क्वायर 2 एंड dx square minus y square 1. Now when this electronic configuration is there, then axial elongation takes place. क्या होता है इस केस में? इस केस में एक्सियल इलोंगेशन होता है. ठीक है, सो दिस इज द एक्सियल इलोंगेशन. ये कौन सी केस है? दिस इज एक्सियल इलोंगेशन केस. इट इज कॉल्ड एज एक्सियल इलोंगेशन. This is called as axial elongation. When axial elongation takes place, when dz square have more electrons. क्या है इस केस में? dz square में इलेक्ट्रॉन्स क्या है? ज्यादा है. तो ये z एक्सिस है, आप लोगों को पता है, मैंने बोल दिया था. इधर है, हाँ इधर है, ये z एक्सिस है. तो वही ट्रिक, सेम ट्रिक यहाँ पे हम लोग अप्लाई करेंगे। डी जेड स्क्वायर में क्या है, इलेक्ट्रॉन्स ज्यादा है, डी जेड स्क्वायर में इलेक्ट्रॉन ज्यादा है, तो डी जेड स्क्वायर की बॉन्ड लेंथ भी क्या होगी, ज्यादा होगी। डी जेड स्क्वायर की बॉन्ड लेंथ भी क्या होगी, ज्यादा होगी एज कंपेयर टू दिस फोर लिगेंड्स। सो दिस फोर लिगेंड्स दे आर कॉल्ड एज इक्वेटोरियल लिगेंड ना, एल ए बी सी डी। दिस फोर लिगेंड्स ए बी सी डी, they are called as equatorial ligand, they are called as equatorial ligands, and these E and F, these ligands they are called as axial ligand, they are called as axial ligand. So understood, अगर dz स्क्वायर में इलेक्ट्रॉन्स कम है तो उस केस में एक्सियल कॉम्प्रेशन होगा, और अगर dz स्क्वायर में इलेक्ट्रॉन ज्यादा है तो उस केस में एक्सियल इलोंगेशन होगा। सो दिस इज द सिंपल फंडा, ये मेरा फंडा है, मैं ऐसे ही याद रखता हूं, ठीक है। हैव यू अंडरस्टूड दिस, ठीक है, समझ में आप लोगों को। सो दिस केस इज कॉल्ड एज ए जेड आउट केस, दिस केस इज कॉल्ड एज जेड आउट केस, इट इज ऑल्सो कॉल्ड एज ए जेड आउट केस, ठीक है। why it is called as a z out case, because the ligands in the z axis, sorry, ligands on the z axis, they comes out, so it is called as a z out case. It is also called as axial elongation, or it is also called as a z out case. So in case number 1, here I will write here on the left top corner, here case 1 is axial compression takes place, axial compression होता है इसमें, ठीक है। so that case is called as z in case, that case is called as z in case, because what happens in that case, the ligands on the z axis they becomes compressed, that's why it is called as a z in case. Case number 1 is called as, sorry, case number 1 is called as axial compression, and this axial compression is also called as a z in case. Case number 2, it is called as axial elongation, case number 2 means it is called as axial elongation, and it is called as a z out case, it is called as z out case, very simple है, ठीक है। अंडरस्टूड दिस, समझ में आ गया क्या ये। देन वी विल गो टू द नेक्स्ट पॉइंट, अगर आप लोगों को समझ में आया तो बोलो जल्दी से। ओके चलो, सो द नेक्स्ट इज, क्या है नेक्स्ट तो क्वेश्चन है, ठीक है। चलो क्वेश्चन सॉल्व कर लेते हैं। क्या क्वेश्चन है, रीड द क्वेश्चन केयरफुली। एवरीवन इज सेइंग यस सर। चलो अगर आप लोगों को समझ में आया है तो नेक्स्ट इज क्वेश्चन है, प्रॉब्लम है। कृष्ण प्रे इज ऑल्सो सेइंग यस सर। चलो गुड। सो नेक्स्ट इज प्रॉब्लम इज देयर, क्वेश्चन है, तो ये भी सॉल्व कर लेते हैं हम लोग। चलो जल्दी से, क्या है क्वेश्चन। क्वेश्चन नंबर 1, which of the following system will show Jahn-Teller distortion। सिंपल है, ऐसे क्वेश्चन फॉर द 4 मार्क्स एग्जाम में आते हैं, ठीक है। क्या है, आप लोगों को जस्ट प्रेडिक्ट करना है वेदर द फॉलोइंग गिवन सिस्टम विल शो Jahn-Teller distortion or not। So question number 1 is what, which of the following system will show Jahn-Teller distortion। Now let us take a D0 system, let us take a D0 system। So D0 system means there is no electron। अगर इलेक्ट्रॉन्स ही नहीं है, so there is no question of Jahn-Teller distortion। इलेक्ट्रॉन्स ही नहीं है तो एक्सियल इलोंगेशन कहाँ से होगा और एक्सियल कंप्रेशन कहाँ से होगा। सो इट विल नॉट शो द Jahn-Teller distortion, it will not show Jahn-Teller distortion, ठीक है। नाउ let us take second point, that is D2 system। D2 सिस्टम क्या है, इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन D2 का, बोलो मुझे D2 का इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है, टेल मी। D2 का इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या है, टेल मी। Grisha, correct. T2G2 and EG0. T2G2 and EG0. So it is symmetrical filling or unsymmetrical filling? Tell me. Correct. Everyone is saying correct electronic configuration. Now tell me T2G2 is symmetrical filling or unsymmetrical filling? क्या है ये? Symmetrical filling है electrons का या unsymmetrical filling से? बोलो. It is symmetrical or unsymmetrical? अरे क्या हुआ? Unsymmetrical. Vaibhav is saying symmetrical. No, Vaibhav. It is not symmetrical filling. Jay is also saying symmetrical. Why it is will symmetrical? उसमें half filled है क्या? It is less than half filled, so it is unsymmetrical filling. It is unsymmetrical filling. It is unsymmetrical. Correct. Komal, Tanusha, they are saying unsymmetrical. अगर unsymmetrical filling है तो this system will show Jahn-Teller distortion or not? Tell me. क्या ये Jahn-Teller distortion show करेगी? हाँ या नहीं? करेगी कि नहीं करेगी? Unsymmetrical filling है. Grisha is saying no. Why, Grisha? Can you explain your answer? Everyone is saying no. Jay is saying yes, it will show. Now those are saying no, na? Please explain your answer. Explain your answer. Grisha, Renuka, Tanuja, Vishwajit, Saurav, Rohan. Explain your answer. Why it will not show Jahn-Teller distortion? Yes, Krishna Priya ने 100% सही आंसर दिया. Yes, but magnitude will be low. Correct. Very good. It will show the Jahn-Teller distortion, but the magnitude is low. क्योंकि अनसिमेट्रिकल फिलिंग है इलेक्ट्रॉन्स का T2G ऑर्बिटल्स में. अगर T2G ऑर्बिटल में अनसिमेट्रिकल फिलिंग है इलेक्ट्रॉन्स का, then it will show the Jahn-Teller distortion, but its magnitude is low. Because it is in T2G orbital, it will experience negligible. क्या था कमेंट में पढ़ नहीं पाया. ठीक है. So T2G2 orbital will show Jahn-Teller distortion, but its magnitude is less. ठीक है. Okay, चलो. Then take the another system, D5 system. Take another system, D5 system. First of all, take weak field complex. And tell me electronic configuration. D5 system, first we will take weak field complex, then another case we will take strong field complex. And tell me the electronic configuration for both complexes, weak as well as strong field. Jaldi. First tell me weak field. वीक फील्ड का बोलो मुझे पहले. T2G3, Grisha, correct, very good. T2G3 and EG2, correct. Now tell me, this is symmetrical filling or unsymmetrical filling? Tell me, T2G3 and EG2, this is symmetrical field or unsymmetrical field orbital? Komal, Krishna Priya, correct. Your answer is correct. No doubt. But tell me whether it is symmetrically filled or unsymmetrically filled. क्या है? Symmetrically filled है. Correct. Krishna Priya, correct answer. Vishwajit also, Grisha is also saying symmetrically filled. Because here, in case of T2G, it is exactly half filled. Because total capacity 6 की है, 3 electrons है, so it is half filled. And in case of EG also it is exactly half filled. Total capacity 4 की है, 2 electrons है, so it is half filled. When there is half filled electronic configuration, then that is called as a symmetrical filling. And it will not show, it will not show Jahn-Teller distortion, it will not show Jahn-Teller distortion. ठीक है, अगर सिमेट्रिकल फीलिंग है तो उस केस में Jahn-Teller distortion नहीं होता है. करेक्ट. ओके चलो देन टेल मी द इलेक्ट्रॉनिक कॉन्फ़िगरेशन व्हेन द कॉम्प्लेक्स इज स्ट्रॉन्ग फील्ड. स्ट्रॉन्ग फील्ड का बोलो इलेक्ट्रॉनिक कॉन्फ़िगरेशन मुझे. D5 in weak field, it will not show Jahn-Teller distortion. Please remember, D5 weak field, it will not show Jahn-Teller distortion because there is a symmetrical filling of electrons. Now D5 in strong field, D5 in strong field, correct. T2G5 and EG0, correct. So here T2G5 and EG0, T2G5 and EG0. So whether it is symmetrical field or unsymmetrical field, tell me. This is symmetrically filled or unsymmetrically filled? T2G5 क्या है? चलो जल्दी से आंसर करो. Unsymmetrical field, correct, very good. It is unsymmetrical field. ठीक है. सो अनसिमेट्रिकल फीलिंग है तो इट विल शो द Jahn-Teller distortion. It will show Jahn-Teller distortion, but its magnitude is less. ठीक है. So D5 in weak field will not show Jahn-Teller distortion. D5 in strong field will show Jahn-Teller distortion. Now take fourth one. Fourth is D9. Fourth is D9 system, and D9 system in strong field as well as weak field is similar. D9 system in strong as well as weak field is similar. So tell me electronic configuration of D9 system. Tell me electronic configuration of D9 system जो कि strong और weak field में same ही होता है. ठीक है. The electronic configuration of D9 system in strong field and weak field is same. T2G6 and EG3, correct? T2G6 and EG3. T2G6 and EG3. So here T2G orbitals, they are symmetrically filled. Here T2G orbital, they are symmetrically filled, and EG orbital, 3 electrons are there. 3 electrons are there. It is unsymmetrically filled. It is unsymmetrically filled. So it will show a Jahn-Teller distortion with higher magnitude. Correct. Grisha ने सही बोला. It will show Jahn-Teller distortion with higher magnitude. So in this way you have to solve the question based on Jahn-Teller distortions. So here I have given the D system. आप लोगों को हो सकता है कि D system नहीं देंगे वो लोग. They will give you the example, for example K3FeCN6, and they will ask you to predict whether this complex will show Jahn-Teller distortion or not. Then you have to first find out the oxidation state, you have to find out the D system, and then do the splitting based on the ligand present. Do the splitting of the electrons, fill the electrons, then write down the electronic configuration, see whether the filling is symmetrical or unsymmetrical field. If the electronic configuration is symmetrically filled, then it will not show Jahn-Teller distortion. If the electronic configuration is unsymmetrically filled, it will show Jahn-Teller distortion. Simple है. ऐसे आप लोगों को solve करना है. Now tell me, have you understood this theorem or not? That is Jahn-Teller distortion theorem. आप लोगों को समझ में आई है क्या? Tell me. Then we will go to the next point. बोलो. Yes, विक्रम ने पहले ही आंसर दिया. Very good, विक्रम. Vikram have understood the Jahn-Teller distortion or tetragonal distortion. Please remember this. Jahn-Teller distortion, it is also called as a tetragonal distortion. बहुत से बार बच्चे कंफ्यूज हो जाते हैं. उनको Jahn-Teller distortion का सब आता पता रहता है, लेकिन एग्जाम में पूछा जाता है टेट्रागोनल डिस्टॉर्शन एंड दे गेट कंफ्यूज्ड, अरे यार व्हाट इज दिस टेट्रागोनल डिस्टॉर्शन. सो टेट्रागोनल डिस्टॉर्शन एंड Jahn-Teller distortions both are same. John and Taylor, these two are the name of scientists. That's why it is called as a Jahn-Teller distortion. And after distortion, that geometry becomes tetragonal. After the distortion, that geometry becomes distortion. That's why also it is called as a tetragonal distortion. ठीक है, चलो. So everyone is saying yes sir, सब लोगों को समझ में आया है. तो we will move forward to the next point. Very simple point. It will require hardly 5 to 7 minutes. That is, the name of next point is factors affecting on magnitude of 10 dq or del O. The next point is factors affecting on the magnitude of 10 dq or del O. So which factors? There are some factors. In D4 the magnitude Jahn-Teller distortion is more, but in D2 the magnitude is less. Why is it so? D4 which case? D4 weak field. अगर D4 weak field है, so here अगर D4 है and weak field है, D4 है and complex is weak field है, ठीक है. So means you have 4 electrons and this is T2g orbital and this is EG orbital. So according to the rule, what happens? The first 3 electrons will go in T2g orbital because T2 is lower in energy, and the 4th electron will go in EG orbital because complex is weak field. Because complex is weak field, weak field complex means the gap between T2g and EG orbital is less. So to go to the EG orbital, electrons will require less amount of energy than the pairing energy. To pair the electrons in T2g orbital, it will require higher energy. So electron will prefer to go into the EG orbital. Now see here, the electronic configuration is T2g3 and EG1. So EG unsymmetrical field है ना, यहाँ पे क्या है? Now Grisha is saying yes sir, understood. ठीक है, चलो अगर समझ में गया है तो चलो. सो बाकी के लोगों के लिए मैं बोल लेता हूँ. T2g3 and EG1. So T2g is symmetrically filled. Here EG is unsymmetrical field. अगर EG में unsymmetrical filling होता है इलेक्ट्रॉन्स का, in that case the Jahn-Teller distortion की magnitude ज्यादा होती है. क्यों ज्यादा होती है? Because the EG orbitals, they have their lobes pointed along the axis, and while forming the octahedral complex, approach of the ligand is along the axis. So along the axis interaction is more. That's why this happens. ठीक है, यह मैंने आप लोगों को पहले लेक्चर में बोला है, वो आप लोग ध्यान में रखो. while forming octahedral complexes, the path of the ligand is along the axis, and while forming tetrahedral complex, approach of the ligands in between the axis. ये आप लोगों को पता ही रहना है, ध्यान में रखना है. ठीक है, ओके, चलो. सर, the factors affecting on the magnitude of 10 dq or del 0, ये हम लोग देख रहे थे ना. चलो, सो कौन से फैक्टर है ऐसे? 3 factors are there. Which factors are there? These 3 factors आपके स्क्रीन पे है, देख लो एक बार. Nature of the ligands. This is the first factor which affect the magnitude of 10 dq. Nature of the ligand. Then oxidation state or charge on the metal. The charge on the metal is also called as oxidation state. So oxidation state and charge on the metal, this is also one of the important factor which affect the magnitude of 10 dq. Then the principal quantum number of d orbital. Principal quantum number means this n. The value of n is also very important. So these 3 factors affect the magnitude of 10 dq. कौन से 3 factor है? First factor is nature of ligand, second factor is oxidation state or charge on the metal ion, and third factor is principal quantum number of d orbitals. That means that d orbitals कौन से प्रिंसिपल क्वांटम नंबर में आता है, उसके ऊपर भी ये मैग्नीट्यूड डिपेंड रहती है. कैसे, वो हम लोग देखेंगे. वन बाय वन वी विल सी. सो फर्स्ट वी विल टेक द नेचर ऑफ लिगैंड. ये आप लोगों को पता ही है, आप लोगों ने पूरा CFT का चैप्टर ही इसके ऊपर डिपेंड है. फर्स्ट क्या है? नेचर ऑफ लिगैंड. सो नेचर ऑफ लिगैंड, 2 टाइप्स ऑफ लिगैंड्स आर देयर. स्ट्रॉन्ग फील्ड लिगैंड है, फॉर एग्जांपल साइनाइड माइनस NCO. अगर स्ट्रॉन्ग फील्ड लिगैंड है तो क्या होगा? गैप बिटवीन T2g इन EG ऑर्बिटल विल बिकम मोर, एंड अगर गैप ज्यादा है तो उसकी मैग्नीट्यूड क्या होगी? 10 dq की ऑब्वियसली ज्यादा ही होगी. सो स्ट्रॉन्ग फील्ड कॉम्प्लेक्सेस हैव हायर वैल्यू ऑफ 10 dq देन द वीक फील्ड कॉम्प्लेक्सेस. ये हम लोगों ने पहले ही देखा है, एग्जांपल सॉल्व भी किए हम लोगों ने बहुत से सारे. ठीक है. देन सेकंड इज वीक फील्ड लिगैंड. वीक फील्ड लिगैंड है, दैट मींस द गैप बिटवीन T2g ऑर्बिटल इज नाउ लेस. Gap less है, that means the energy between T2g and dt, energy difference between T2g and EG orbital is also less. So the magnitude of 10 dq is also less. So first is factor is आप लोगों को पता है, that is the nature of ligand. ठीक है, ये आप लोगों को पता है, nature of ligand. Then सो फॉर स्ट्रॉन्ग फील्ड लिगैंड का कौन सा एग्जांपल है, साइनाइड माइनस एंड कार्बोनिल। देन वीक फील्ड के वाटर है, क्लोराइड है, इथिलीन डायमाइन एंड pyridine है, ठीक है। ओके चलो, देन द सेकंड फैक्टर इज ऑक्सीडेशन स्टेट और चार्ज ऑन द सेंट्रल मेटल आयन। Oxidation state or charge on the metal ion. The charge on the central metal ion or oxidation state of central metal ion has direct effect on the magnitude of 10 degree. ये ऑक्सीडेशन स्टेट है और चार्ज ऑन द मेटल है, इसका डायरेक्ट इफेक्ट होता है किसके ऊपर, द मैग्नीट्यूड ऑफ 10 DQ के ऊपर। कैसे होता है, लेट अस सी क्या है। लिसन द सेंटेंस केयरफुली। ग्रेटर द पॉजिटिव चार्ज ऑन सेंट्रल मेटल एटम, greater the positive charge on the central metal atom, greater is the attraction towards the negatively charged ligand. ये तो आप लोगों को पता है, ligands are negatively charged because they contains electrons. and अगर मेटल के ऊपर ग्रेटर पॉजिटिव चार्ज है तो क्या होगा, उसमें अट्रैक्शन ज्यादा होगा। अट्रैक्शन ज्यादा मीन्स बॉन्ड फॉर्म इज ऑल्सो ज्यादा, बॉन्ड फॉर्म ज्यादा है तो क्या होगी उसकी, सो इट विल शो हायर वैल्यू ऑफ 10 DQ. so it will show higher value of 10 DQ. That means the oxidation state is directly proportional to the magnitude of 10 DQ. क्या है, oxidation state और charge on the metal is directly proportional to the magnitude of 10 DQ. ठीक है, now let us see example. Two examples are there. See, chromium 3 plus will have higher CFAC or 10 DQ value than chromium 2 plus because here oxidation state is 3 plus. That means पॉजिटिव चार्ज इस केस में कैसा है, ज्यादा, यार पॉजिटिव चार्ज इज 2 प्लस, तो 3 ज्यादा है 2 से ना, तो इट विल शो हायर वैल्यू ऑफ 10 DQ. देन सेकंड एग्जांपल इज Fe3 प्लस विल शो हायर वैल्यू देन द Fe2 प्लस। मींस ऑक्सीडेशन स्टेट अगर कॉम्प्लेक्स की ज्यादा है, सॉरी कॉम्प्लेक्स की नहीं, सेंट्रल मेटल एटम की ज्यादा है, तो उसकी 10 DQ की वैल्यू भी क्या होगी, ज्यादा ही होगी। So this charge on the metal ion has direct effect on the value of 10 DQ. And how? The charge or oxidation state is directly proportional to the magnitude of 10 DQ. The charge or oxidation state is directly proportional to the magnitude of 10 DQ. Understood this second? Then we will go to the third. That is principal quantum number of the orbital, which is n. Principal quantum number is n. कैसे अफेक्ट करता है, लेट अस सी हाउ दिस प्रिंसिपल क्वांटम नंबर अफेक्ट्स द मैग्नीट्यूड ऑफ 10 DQ. लेट अस सी. सो हियर द मैग्नीट्यूड ऑफ क्रिस्टल फिeld splitting greater for the complexes containing 5D electrons than the 4D and 3D electrons. ठीक है, समझ में आया। अगर आपका मेटल एटम थर्ड रो से है, अगर आपका मेटल एटम थर्ड रो से है, थर्ड मीन्स 5D सीरीज से है, थर्ड रो मीन्स इट इज 5D सीरीज। फर्स्ट रो मीन्स सी हियर, फर्स्ट रो मीन्स 3D, second row means 4D and third row means 5D. And if your metal atom is from 5D orbital or third row series, then it will have higher value of 10 DQ, then the 4D and then the 3D. ठीक है, okay. The next point is the magnitude of crystal field splitting is the order of 5D is greater than 4D and 4D is greater than 3D. Remember, please remember this order ना, 5D की 10D की वैल्यू ज्यादा होती है किससे, 4D से, और 4D की 10D की वैल्यू ज्यादा होती है किससे 3D से. So the order of magnitude of crystal field splitting is the order of 5D is greater than 4D and 4D is greater than 3D. ठीक है, okay. Then the next point. Now here 5D orbital and 4D orbitals forms only strong field complexes. क्या है इसका मीनिंग, ये हम लोगों ने फर्स्ट पॉइंट और सेकंड पॉइंट जो ये दो पॉइंट देखे ना, इसका मीनिंग नीचे है. 5D and 4D orbital forms only strong field complexes. Now please remember, when you have metals from 5D and 4D series, then you have to show the splitting for strong field complexes only. And whether it is from अगर वो 3D orbital से है, that means first row से है, it can form a strong field as well as weak field complexes. ये तो हम लोगों ने देखा है, हम लोगों ने जो कुछ भी एग्जांपल देखे, all the examples or all the metals they are from first row or 3D series. They are from first row or 3D series. That means they will show strong field as well as weak field complexes. Which complexes, which metal atom, which metal show strong field as well as weak field? Those which comes from first row or 3D series. Those which come from first row or 3D series. And for second row, that is 4D series, and third row, that is 5D series, they will only show strong field complexes. That metal only form strong field complexes. ठीक है, understood how this principal quantum number affect the magnitude of 10 dq? समझ में आया आप लोगों को? चलो, तो ये भी क्वेश्चन आता है, एक्सप्लेन द फैक्टर्स अफेक्टिंग ऑन द मैग्नीट्यूड ऑफ 10 dq. ये क्वेश्चंस 100% आता है. So you have to write down these three factors: nature of the ligand, then oxidation state or charge on the central metal ion, and third is principal quantum number of d orbital, that is n. ठीक है. Now I think we will stop here. Now we will stop here. If you have any problem, you can ask me. If you have any problem, you can ask me. If you have any problem, any doubt, you can ask me. नो प्रॉब्लम और नो डाउट. वेरी गुड. आप लोगों को सब समझ में आया है आज का लेक्चर. नो प्रॉब्लम. थैंक यू सर. विश्वजीत इज सेइंग. ठीक है विश्वजीत. Now I will active the link for your attendance. So you can give the attendance. Krishna Praise is saying thank you sir. Okay, sure, no problem. So shall I stop here? If no problem, then I will stop here. I have given the link for your attendance. Go there and give your attendance. ठीक है? So shall I stop here? Okay, chalo. So this is Kishore Kale signing off. Take care. Bye bye.